Imagine looking up at the night sky, stars, planets, galaxies, all so vast and beautiful. Yet what you're seeing is only 15% of the universe. The rest, it's invisible, something scientists call dark matter. But what is it, and how does it shape the cosmos we live in? How can something so powerful, so essential, be completely invisible? What does dark matter hide from us? And how does it hold the secrets to the very fabric of our universe? Despite the monumental discoveries we've made about the universe, dark matter remains one of the greatest mysteries. It's the force that holds everything together, yet we can't see it, feel it, or measure it directly. So what are we missing? Today, we unravel what scientists know and don't know about dark matter and explore how its discovery might reshape our entire understanding of reality. But before we dive into what dark matter might be, let's first explore why scientists believe it exists at all. What clues does the universe give us about this hidden force? In the 1930s, Swiss astronomer Fritz Zwicky noticed something strange while observing distant galaxy clusters. The galaxies were moving so fast that they should have flown apart, and yet they stayed together. It was as if an invisible glue was holding them in place. Zwicky called this glue dark matter. But why? Imagine watching race cars speeding around a track at breakneck speed. Suddenly you realize they should be skidding off the track, but somehow they stay in control. That's what Zwicky observed in galaxy clusters. These galaxies were moving far too fast to be held together by the visible mass alone. The missing glue, dark matter. Decades later, in the 1970s, astronomer Vera Rubin made another game-changing discovery. She noticed that stars in individual galaxies weren't behaving as expected. According to Newton's laws of gravity, stars on the outer edges of galaxies should move slower than those near the center. But what Rubin found was that these stars were moving just as fast as those closer to the core. Something was exerting a gravitational force on them, something we couldn't see. To put it into perspective, imagine the solar system. The planets closest to the sun orbit more quickly, while the outer planets, like Neptune, orbit slowly. Rubin found that in galaxies, this rule wasn't holding up. The outer stars weren't lagging behind, they were racing ahead. It didn't add up, unless you considered one thing: dark matter. Rubin's discovery confirmed what Zwicky had suspected. There's far more to the universe than meets the eye. Dark matter, though invisible, seemed to make up most of the universe's mass. But what is it made of? Could it be something we've never seen before? Before we uncover what scientists think dark matter might be, let's pause and ask, what does the universe hide from us, and could dark matter be the missing key to unlocking a whole new realm of physics? We know dark matter exists, but what exactly is it made of? For decades, scientists have proposed theories, conducted experiments, and tried to detect what remains invisible to our eyes and instruments. So far, the candidates for dark matter remain elusive, but each brings us closer to the answer. The most popular candidate is called WIMPs, or weakly interacting massive particles. These particles are thought to be massive compared to other particles, yet they barely interact with normal matter. Think of WIMPs like ghosts. They pass right through us, through the Earth and through the entire universe without leaving a trace. Despite massive underground detectors built to catch a WIMP in action, scientists have yet to detect them. But WIMPs aren't the only possible explanation for dark matter. Another candidate is axions, tiny lightweight particles that are believed to interact with matter in a way so subtle that they remain hidden. Imagine trying to catch a feather falling in complete darkness. That's what axions are like, elusive, but potentially out there. There's also a more radical idea. Dark matter might not be made of particles at all. Some scientists believe that tiny ancient black holes formed shortly after the Big Bang, called primordial black holes, could make up dark matter. Though invisible, these black holes could still exert a gravitational pull, strong enough to account for the missing mass we observe. But even after decades of research, none of these candidates have been confirmed. Are we looking in the wrong place? Or could dark matter be something far more unexpected? Could dark matter exist in dimensions beyond our own? Could it interact with forces we don't yet understand? Let's explore the possibilities of dark matter as something even more exotic. Chapter 4. Could we be missing something bigger? Some scientists are beginning to think we might be asking the wrong questions. What if dark matter isn't made of particles at all? What if it behaves in ways we can't even imagine, like a wave rather than a particle? Or what if dark matter interacts with forces entirely unknown to us? One theory suggests that dark matter might not behave like particles at all, but rather like a wave. Imagine ripples of invisible energy flowing through the universe, subtly shaping galaxies without us even realizing it. This wave-like dark matter would explain why we haven't been able to detect it using traditional methods focused on particles. Another exciting possibility is the dark sector theory. What if dark matter interacts with its own set of laws, laws that are completely different from the ones that govern regular matter? Imagine a hidden world running parallel to our own, with its own forces and dimensions that are invisible to us. Dark matter could be part of that hidden universe, interacting with ours in ways we can't yet understand. If dark matter exists in another dimension or behaves like a wave, how can we ever hope to detect it? Could it be that we're not just searching for particles, but for an entirely new form of reality? And if dark matter exists in dimensions we can't access, could it hold the key to even greater mysteries, mysteries that could reshape our understanding of time, space, and energy? Chapter 5. The Future of Dark Matter. Research. Even though dark matter has remained invisible, scientists are closer than ever to unlocking its secrets. New technologies and upcoming experiments are offering hope that we might soon understand the true nature of this mysterious force. So what's next in the search for dark matter? Quantum computers are revolutionizing the way we understand the universe. Unlike classical computers, which process one piece of data at a time, quantum computers can handle an enormous number of variables simultaneously. This means they can simulate highly complex interactions, including those related to dark matter, which are impossible to replicate with today's technology. With quantum simulations, we might finally be able to model dark matter's behavior on a subatomic level. Quantum computing is just one piece of the puzzle. The next generation of space-based observatories is also bringing us closer to understanding dark matter. The James Webb Space Telescope, launched in 2021, is now offering us deeper insights into the universe than ever before. Its unprecedented resolution allows scientists to gather new data on galaxies, stars, and the gravitational effects of dark matter. Meanwhile, the Rubin Observatory, set to launch soon, will map dark matter's distribution across the entire sky, offering a complete view of how dark matter is spread throughout the universe. With these tools, scientists are piecing together more and more clues about dark matter. But as we get closer to understanding its nature, the question remains, what will discovering dark matter truly mean for our understanding of the universe? And if we unlock the mystery of dark matter, could it lead to even greater discoveries, ones that could reshape not only our understanding of space, but of time, energy, and even life itself? Chapter 6. Conclusion. What if we find it? The search for dark matter is about much more than finding a missing piece of the universe. It's about rethinking everything we know about the cosmos. If we do discover the true nature of dark matter, it could lead to breakthroughs in our understanding of gravity, energy, and even the fundamental laws of physics. The discovery of dark matter could open the door to new forms of energy, technologies we can't even imagine, and possibly a deeper understanding of the very fabric of reality. Just as the discovery of electricity transformed the modern world, unlocking the secrets of dark matter could lead to unimaginable scientific and technological advances. But dark matter's secrets aren't just about the future. They're about understanding the most basic forces that govern everything we know. By finding it, we're not just discovering a new particle, we're potentially uncovering an entire hidden realm of physics. So, what do you think dark matter could reveal? Could it unlock new energy sources, lead to breakthroughs in space travel, or open our eyes to hidden dimensions we've yet to explore? Leave your thoughts in the comments and don't forget to subscribe to the Unseen Truths as we continue our journey into the greatest mysteries of the universe.